A consistent theme for questions about my GMRS radio reviews centers around repeaters. Let's take a look at the why and the how of GMRS repeaters. Hi, and welcome to the Gadget Talk channel, where we do reviews and how-tos on a variety of gadgets that catch my eye. If you find this video helpful, please like, comment, share, and subscribe to the Gadget Talk channel. I really appreciate it. If one of my GMRS radio reviews generates a question, odds are it's about programming repeaters. In this video, we'll take a quick look at what GMRS repeaters are, why they're important, and some of the key terms you'll need to understand when programming a repeater into your radio. Let's start with a thumbnail sketch of what GMRS repeaters are and what they do. GMRS radios work in the UHF frequency bands at about 462 megahertz. That means that unlike the HF or high frequency bands, UHF radios are what's called line-of-sight radios. UHF radio waves basically go straight, so the person you're communicating with has to be visible to you, at least theoretically. The radio's output power extends the range of the signal, but your communications partner still has to be in sight. UHF signals can be lessened by things like dense vegetation, buildings and hills or mountains that limit line of sight. There are two ways to extend your GMRS radio's range, and that's where repeaters come in. The first way is to increase power to the maximum allowed by the regulations. The second way is to raise the height of the antenna. Most repeaters do both of those things. Repeaters often use close to the 50 watts allowed by the regs and are usually placed on high buildings or hilltops. Along with high-quality antennas that allow their receivers to receive low-level signals, repeaters greatly increase your radio's reach. The repeater repeats your call by simultaneously receiving and then rebroadcasting your transmission on the repeater's output frequency at the repeater's higher power level and elevation. The output frequency is automatically set to 5 megahertz lower than the input frequency. There are 8 GMRS repeater channels specified in the GMRS band plan. They are labeled as channels 23 through 30, or repeater channels 15 through 22. You'll often see them as 15R and 16R and so forth. That's because the output channel for the repeater channel 15R is the same as the GMRS channel 15, and so on. If you've ever been monitoring channels 15 through 22 and you hear people but they don't answer, it's likely that they are using a repeater and you are out of their line of sight range. With this operating model in mind, let's circle back and define some terms. Let's start with some frequency terms. First is input frequency. The input frequency or channel is the channel the repeater listens to. When it hears a transmission, it resends it out 5 megahertz lower. Next is the output frequency. This is the frequency the repeater retransmits your call. It's also the frequency that the repeater is listed on under sites like mygmrs.com. This is where things can get confusing. For example, the frequency listed in mygmrs.com is the output frequency, which corresponds to the frequency in the GMRS channel range of 15 to 22. However, if you were to tune channel 15, for example, you wouldn't trigger the repeater since its input frequency is 5 megahertz higher. To use a repeater with a listed frequency corresponding to channel 15 as listed in a repeater directory, you would have to select channel 23 or 15R, which tells your radio to transmit on the higher frequency while listening on the lower frequency. This is called the offset. The good news is that the radio automatically tunes the proper offset for the repeater channel you've selected. This becomes a little tricky when programming your radio using its customer programming software. If the radio has a few do-it-yourself repeater channels, you may need to enter the correct frequency pairings, and things won't work if you get the input and the output backwards. The channel chart on the Wikipedia article on GMRS can be very helpful. Next, let's look at repeater tones. Many repeaters use tones as a way to control what transmissions the repeater rebroadcasts. There are two types of tones used in the GMRS world. These are subaudible tones that tell the repeater to open the squelch and rebroadcast the signal. The first method is called CTCSS, or Continuous Tone-Coded Squelch System. Repeaters using this system are set to listen for a subaudible tone on a specific frequency that allows the signal to pass through to the repeater's transmitter. CTCSS codes are specified and range from 67 Hz to 254.1 Hz. You must set the tone on your radio to match the input tone specified in the repeater directory. If you fail to set the tone or set the wrong one, the repeater won't respond. Some repeaters will also specify an output tone. By setting the output tone in your radio's receive tone menu, you'll hear the repeater but not the other chatter that might be occurring on that output channel. Repeater owners may set their repeaters to use different tones for input and output. This is called split tone operation. This allows the repeater owners to make it a bit harder to use the repeater's input by not publishing the input tone publicly. These are the same tone settings you can use on non-repeater GMRS channels to limit chatter on GMRS channels to only the folks using the specified tone. The second type of tone is called DCS, or Digital Coded Squelch. The technology behind this system is different than CTCSS, but it serves the same purpose. There are over 200 DCS codes to choose from. Again, with both systems, the tone tells the radio to open the squelch to allow this signal to pass. These systems are used to prevent users from triggering more than one repeater simultaneously. With older and more basic GMRS radios, you'll need to enter the radio's menu system and set the proper tones on the repeater channel you plan to use. In areas with lots of GMRS activity, this becomes inconvenient when there may be two or more repeaters on the same repeater channel that you'd like to use. Newer radios have added what are called do-it-yourself or custom repeater channels. Different models use different schemes, but basically you're allowed to program additional repeater channels, give them names, and input different CTCSS or DCS codes to make switching between repeaters on the same channel easier. FCC regulations don't allow GMRS certified radios to transmit on user input frequencies other than those approved for GMRS use. This means you'll be entering the frequency pairing or using the pre-programmed duplicate repeater channels depending on how your radio's manufacturer chose to implement their DIY scheme and stay within the FCC regs. Now, to make this just a bit more confusing, the folks that build customer programming software, or CPS, use different terms to mean the same thing when it comes to tones. Transmit and receive are the most common terms. These are pretty easy to understand. The code you place in the transmit column is what goes out when you transmit. This must match the input tone on the repeater. The code that goes in the receive column is the code your radio listens for to break the squelch. It should match the repeater's output tone. Some manufacturers, however, use the term encode and decode. Encode corresponds to the transmit and decode corresponds to receive. Let's take a quick look at a couple of radio CPS channel displays. So here's the channel display for the UV9G handheld GMRS radio. And so you can see these are all there. You can't really make any changes to these. They come with the CTCSS codes off, but you can make changes using the drop-down boxes, going through the various CTCSS codes and the DCS codes, and you just select them. You can also make changes to the transmit, CTCSS. You can add them to your scan list and so forth, and they have a name, as you'll notice here, added to the last field in the database. And as we get down here, you also see that channels 9 through 14, also sometimes referred to as the interstitial, which means in between channels, are the low power, narrow band channels. People think of them as FRS kinds of channels, but they are there. You can use them with your GMRS radio, but they're lower power and they're only available by regulation to handheld radios. We'll notice a change in that here with one of the other displays. Now, in terms of do-it-yourself choices with this particular radio, you can see here that you've got repeater channels 1 through 8 in channels 22 through 30. That's the standard repeaters, and you can make changes to the codes and so forth. And then there are 3 banks of 8 do-it-yourself channels. And so you can see here channel 31 has a receive frequency of 462 5500. You can see that 452 5500 occurs again down here, and then it occurs again down here. So in this particular scheme, you have to choose the channel that corresponds to the channel that's programmed into that. So you can have up to 4 repeaters with the same repeater channel with different codes using this scheme. Now let's move to a different radio. Now this display is for the Radioddity GM30 GMRS radio, and you can see that each channel has a name, channel 1, channel 2. Again, the narrow and low power are assigned to these interstitial channels 8 through 14. Then we move back up to wide and high power through the rest of the channels. These that are gray are controlled. They're not, you can't make changes to. But here you can see that down here we get into channels 31 through 54, and we still have this blocks of channels here. So if we make this to 462 6000, and we see that we get the difference dialed in, and so now DIY channel 1 is 462 6000, which is the equivalent to repeater 3. And if we wanted another repeater 3, these things can all be set. So you have a pretty much between channels 31 and channel 54, you can set as many of those frequencies as you want using the drop down. It will automatically compute the offset, and then you can add whatever tone and power setting that you want in these other drop down boxes. And so here on channel 56, I set in 146 5200, a ham radio frequency. You notice this is dark because it's not allowed to transmit in that area. You'll also see that when I double click it, a drop down box doesn't come in. So these are users selectable receive only channels, and then you can make the various changes here in the drop down boxes that apply. So that's a slightly different take. The first one we looked at had banks of channels. This one has 24 do-it-yourself channels, but you can mix and match them any way you want. Now let's look at a base or a mobile radio channel display. Now in this particular display, we were looking at the Radioddity DB25G mobile radio, and you'll notice that the interstitial channels are blank. That's because mobile or base stations are not allowed to transmit there by regulation. And so we have the basic 1 through 7 GMRS channels with their associated frequencies. We also have 15 through 30 with their associated frequencies. And so when we get down to channel 22, those are the basic GMRS. And then we have a group of repeater only channels in this particular radio. So you've got repeater 15, repeater 16, and they correspond to the frequencies up here that I've talked about already. And so if we want to make a change here, we have the ability to do that in this radio. So here I just added one in. And so I double click there, there's a drop down. When we click there, I was able to type in the frequency. In this case, it was 462,725, which is the same as repeater channel 22. When I did that, this all filled in. I could fill in my power setting and the wide narrow, put in the various CTCSS or DCS codes, and we're able to do that just as we choose in these additional frequencies here on the 725G from Radioddity. So those are 3 common ways that you can deal with programming, do-it-yourself repeater channels, and the various ways that radios implement the restriction of only transmitting on approved GMRS radio channels while giving you the flexibility to set multiple repeaters up on the same channel at the same time that have different CTC or DCS codes. So now let's take a minute to talk troubleshooting. The GMRS license is designed for a system that is limited but easy to use, unlike amateur radio licenses that require testing on rules, radio theory, and operations. With that in mind, if you can't get your radio to connect to a repeater, you're probably making a mistake. Hopefully, the explanations we've just gone through will limit those. The first thing you should try is to add your desired repeater's tone codes to one of the existing repeater channels programmed into your radio using the radio's menu system and faceplate control. As we mentioned, those channels are channels 23 through 30. Use the chart from Wikipedia to ensure the output channel from mygmrs.com matches the repeater channel you select. Next, give your call sign and ask for a radio check. If no one answers, but the repeater sends out a Morse code identifier or a voice identifier, you know you're good. If not, switch the codes in the receive and transmit memories and try again. Mismatched codes are a common error. If you have a second GMRS radio, set it to the repeater's output channel in the 15 to 22 channel range. Don't set any codes and see if your transmission comes through. If it does, you know you have a receive tone problem with the radio you're programming. If that's the case, double check the receive tone or just turn it off. If you still don't get a response, double check that you're within range or that an obstacle isn't between you and the repeater. If you want to use a DIY channel for the repeater, confirm the repeater works in the primary channels as we just described, and then upload your radio settings to the CPS. In so doing, you'll have all the correct information listed in the primary channel display. Then just duplicate the info in a DIY channel using whatever scheme your radio manufacturer uses. That being said, be sure you understand what that scheme is. Some manufacturers use pre-programmed banks of repeater channels, and still others only allow DIY channels in a specific range of channels in the display. Your programming might be perfect, but if it's in channel 99 instead of channel 45, it might not work. Don't forget to save your radio settings to your computer and be sure to write the changes back to the radio before testing again. GMRS repeaters are a great way to expand your coverage area and number of folks you'll be able to chat with. In some areas, you may have to join a repeater club to gain access to the repeater or repeaters that they manage. That seems only fair, as repeaters can be expensive to install and to operate, and they take a fair amount of effort to keep them running at peak performance. Hey, if you found this video helpful, please click the thumbs up button below the video and subscribe to the Gadget Talk channel. Click the bell icon to be notified when I post new videos. Thanks for watching.